I'm a software engineer from Atlassian, and today I'm going to be speaking to you about iterative dashboards and monitors. So basically a story about how we've moved from a little bit of a set and forget approach to our operational resources into something that was a little bit more iterative and agile. We've, in the past few years, adopted a very you build it, you run it kind of style. And I'm sure most of you are familiar with that, but just in case you're not, this is the idea that if you or your team build some kind of application, it's on you to not just maintain the code for that application, but also all of the operational concerns that come with it. And that's fine. But at Atlassian, we were all software engineers. And as software engineers, we were not super used to having to do that. And so there was a bit of a learning curve involved, and we made a few mistakes along the way. And one of the mistakes we made was that we had a tendency to set and forget our operational resources. So basically we came in, we tried to define it all up front and get it all right. And then we put it down and never looked at it again until something fundamentally shit itself. And so as you can imagine, that came with a few negative side effects, which we'll cover throughout this presentation. But thankfully that was actually in the past. And we've managed to come a long way since there, where we've moved towards a much more agile and iterative approach to the definition and maintenance of our operational resources. And we have learned quite a lot in making that transition. And so I'm here today to share with you some of the key learnings that we've made throughout that journey, so that if you were to hear those questions in 6 months' time, you'd all still have your hands up by the end of the presentation. So as for the agenda today, we're going to start off with a few explanations just to make sure we're all on the same page. And then I'm going to tell you a quick story about a project that I've recently worked on in Atlassian. We'll then spend the rest of this presentation taking a deeper dive into how you can decide what to measure, how you can verify that what you're measuring is correct, and how you can help your team keep up to date with change. And then we'll finish up with a summary at the end. But what are we actually talking about today? Well, throughout this presentation, you're going to hear three terms come up quite regularly, and that's metrics, dashboards, and monitors. And so a metric is a measure of a software characteristic. So basically you've taken your application, you've instrumented it in some way, and you've started pushing out some kind of measurements. But some of you might be thinking, how is that different to an analytic? And I wanted to clarify this because when I started having this conversation at work, it turns out this is a very philosophical discussion. And so for the purpose of this presentation, we're going to say that an analytic is something that our users are doing. So in Atlassian, we have Jira, and maybe a user might view an issue, and that would be an analytic. Whereas a metric is something that our systems are doing. So how long did we spend performing database operations to fulfill that view issue request? That would be a metric. So if we see metrics as a collection of data to represent what our systems are doing, dashboards are a visualization of that data. And this can be done in a variety of different ways. We can chart it over time, we can aggregate it into a single value, we can get lots of different metrics and put them in a table. It doesn't really matter. If you've taken your metrics and you visualize them in some way, you probably have some form of dashboard. And then finally, we have monitors. So monitors are an alert that have been defined against one or more of your metrics. Basically, they're a way to monitor that your application is still behaving in the way that you expect. And this can be fairly mild. So maybe you'll send an instant message notification, or they can be a lot more aggressive where you start sending alerts to the person who's on call. And all three of these things are quite broad, and you can have them come in forms such as analytical, strategic, and operational. But for this presentation, we're focusing on those that relate to operational health. And the idea here is that an application with good operational health will help you figure out what went wrong, when the thing went wrong, and why the thing went wrong, all shortly after that thing actually went wrong. So now that we're on the same page, I'm going to tell you a quick story about a project that I've recently worked on at Atlassian. And that's because that project is very relevant to the content that we'll be covering today. But I want you to brace yourselves just a little bit because I do have to cover a small amount about how Atlassian cloud infrastructure works. So it's not too bad. So that's the cloud. And at Atlassian, we run our cloud infrastructure on a multi-tenant architecture. So this just means that a single running application can serve many different customers. So one of the key components within a multi-tenant architecture is the ability to share resources. So if I were to have a Jira and that Jira was made up of a queue, some application nodes, and a database, in order to make sure that Jira was multi-tenant, I would need to make sure it's safe for the various different customers consuming that Jira to share those resources. And that's fine. But at Atlassian, we actually have hundreds of thousands of customers. And so having one big massive pool of resources for everybody around the world to consume from doesn't make a lot of sense because it starts to raise questions with regards to things such as cross-region latency or scale or progressive rollouts and all sorts of other stuff. And so we don't have just one big massive pool of resources, but rather lots of smaller little pools. And we call these shards. So you can see a shard as essentially a collection of resources that are used to run either Jira or Confluence. And a shard will service a subset of our customer base. So the idea is that a customer is assigned to a shard when they sign up with us. So they'll come in, they'll request a product, and we'll hand that request over to the provisioning pipeline. Then a whole bunch of magic happens and the customer ends up on a shard. So if we were to open up that magic just a little bit, we see that it's actually just a collection of different microservices. And one of those microservices is the shard service. So the sole responsibility of the shard service is to select a suitable shard for a customer at provisioning time. And a suitable shard is based on two factors. The first is geographic location. So is the shard physically near to the customer who's making the request? We then look at whether that shard even has capacity to take on more customers. And in order to answer that second question, the shard service needs to keep track of dynamic capacity metrics to represent the capacity of all the different shards at any point in time. But I mentioned before that shards are a collection of resources, and theoretically any one of those resources could become strained. And so we don't look at just one metric, but rather many different metrics, all representing the various different capacities of the resources from the shards. The shard service can then take the limiting factor, and it uses that to denote the overall capacity of the shard. Okay, so now you'll understand how the infrastructure works, but you might be wondering why the hell you needed to know any of that stuff. And the reason for it is because the primary purpose of the shard service was to really just collect and analyze metrics. And that meant that this project was all about metrics, monitors, and dashboards. And during my time working on it, I learned 3 big lessons. Understanding what to measure is pretty hard. What worked today from an operational standpoint was not necessarily going to work tomorrow. And keeping everyone and everything up to date was also pretty hard. And that's pretty much the content of this entire presentation. So throughout this talk, we'll be referring back to the shard service to pull some examples to help explain some concepts that we'll be covering today. And so on that note, we'll start speaking about how you can decide what to measure. In the words of Sherlock Holmes, it is a capital mistake to theorize before one has data. And we all know he was obviously talking about software engineering when he said that. And so we need to go and get ourselves some metrics. But that then lends to the question of what metrics should you collect? And it turns out that's not the easiest question to answer, especially in the beginning of development, because you don't really know what your application is going to do or how it's going to fail. And we were experiencing that in the shard service. So we noticed that that uncertainty would lead to a few temptations. Maybe we could measure nothing. Basically, we could accept zero visibility into the operational health of our application. And that doesn't sound awesome, but it kind of feels somewhat logical during development because no one's even using your application yet. So we figured maybe it's not a big deal if we just add all of our metrics right before going live. But when we thought about that, that comes with a few trade-offs. It means that our metrics aren't going to be verified before rolling out. It's kind of like shipping a dev version of your operational resources to your customer. And that means that our first incident was probably going to suck because we probably weren't going to be collecting the right things or using them in the right way. And this isn't even a solution. It's just a deferral of the problem. So this isn't so awesome. Maybe we can measure everything. We can instrument everything that we can think of just in case. And oh my God, that's amazing because now we have 100% visibility of our application all the time. But again, few trade-offs. To begin with, it's expensive, both in time spent doing that instrumentation and also money, because it costs a lot to collect and store that much data, especially in a way that's searchable and aggregatable. It creates a lot of noise, and so it becomes very difficult to differentiate between what's important, what's unrelated, and what's a red herring. And it really doesn't scale. So if you start telling your devs to remember all your metrics when you're collecting all the metrics, that gets pretty old pretty fast. But surely there has to be some kind of in-between, right? Well, we figured maybe we can measure the things that come out of the box. And that sounded pretty good to us because at Atlassian, we use AWS, so we can get all the metrics from CloudWatch. And we use Java, so we can get heaps of free stuff about our JVM. And that gives us a lot of metrics. So we figured we switched them on and we created a dashboard. So pretty good dashboard here. We've got some good stuff like CPU, got some latency, got some network. Sweet. Now we need some monitors. So we don't really want CPU sitting at over 80% for more than 5 minutes because that's really bad and we should definitely alert. And yeah, that's pretty much it. So operational maturity has been reached and we can now move on with development. And that's what we did. And we rolled out and everything was awesome. until we started to receive an alert from one of the other services in our provisioning pipeline. And this alert was saying provisioning had started to fail because the shard service had stopped returning any suitable shards. That was pretty weird because when we looked at our dashboard, it was looking pretty good. And so we looked into the problem and we found out that this was because the shards were full. So there were no suitable shards for the shard service to return. And thankfully, that was a fairly easy problem to resolve, but it really emphasized that we were not looking at the right things. So we decided to take a step back and we really asked ourselves what questions we wanted to be able to answer with our operational resources. And we found that in order to answer this question, we needed to have a really good understanding of the roles and responsibilities of our application. So the shard service was there because we had to perform the selection of a suitable shard based on geographic location and dynamic capacity metrics. And with that in hand, we can then start thinking about what it looks like when our service's ability to fulfill those roles and responsibilities starts to degrade. So the shard service is a synchronous HTTP pacing service. And so that lends to a few obvious things that could go wrong. Maybe the requests slow down significantly, or they're accepted but then start to fail, or maybe they're just rejected altogether. That all sucks and we definitely don't want any of it to happen, but it's not really specific to the shard service. Any synchronous HTTP facing service is probably going to have similar concerns. But then there's a few things that are less obvious. So maybe there are no suitable shards, or incorrect shards have started to be selected, or maybe there's just not enough data to make any suitable decisions. And this really emphasized the difference between infrastructure metrics and application metrics, where a useful infrastructure metric is something that is tied to a component within your tech stack. So you could have 10 different developers all with the exact same queue, but they're from completely different companies. And every single one of those devs cares that their queue became congested. But then you have application metrics, where a useful application metric is something that is tied to the domain of your application, and only you can know what that is. And so we found that in order to have a good holistic view of our application health, we needed both. And so we continued to capture our infrastructure metrics, but then we also started to push out custom application metrics as well. So one example of this was the shard capacity, which was the understanding that the shard service had on what the capacity of was of all of those shards. And we also then started pushing out things such as the number of errors that we were logging and the reasons we were selecting shards. And with that, we were able to create 3 dashboards this time. One to give us a snapshot overview of the capacity of all of our shards at any point in time. Another to show us why and how we were selecting shards. And then we still had our infrastructure dashboard because that was still really important information. We also revisited our monitors to realize we don't give a shit about CPU because shard service was not a CPU intense application. And so CPU was not necessarily indicative of performance degradation. But we did care about things such as shard or region capacity being exhausted or seeing a surge in errors being logged by our application. And so how can you figure out what to measure? Well, we found that we really needed to understand what questions we wanted to be able to answer. And figuring that out was also kind of hard. And so a bit of structure that we found helpful was to think about why our application exists in the first place. So what are its roles and responsibilities and how important is that application? You can then think about what it looks like when your service cannot fulfill those roles and responsibilities. And then you can think about how to verify whether or not such a degradation has occurred. Okay, so you figured out what to measure, but how can you then verify that you're still collecting the right stuff and using it in the right way? We found that at this point, it's pretty tempting to think we got it all right because we just spent all this time answering these difficult questions. But as time went on, a few things started to happen. Things changed because, we're agile, we're iterative, and we're developing on our cool applications and everything is getting better all the time. But that meant that what worked from an operational standpoint today wasn't necessarily going to work tomorrow. So an example of that was we had all of our services running behind an elastic load balancer, which was just the load balancer provided by AWS at the time. And with that, we got heaps of metrics. But then AWS rolled out the application load balancer, or ALB. And the ALB was meant to be way better, and so we rolled that out across all of our applications. And that brought with it completely different metrics. And we knew that, and so we went around and we updated all of our different dashboards and monitors. But my team didn't just maintain the shard service. We maintained 13 highly critical platform services at Atlassian cloud infrastructure. So that meant we had a lot of dashboards and monitors, and we missed a few places. And everywhere we missed was completely broken. we started to receive a lot of alerts that were either not actionable or just not at all useful. And that meant that we would start to ignore them. So one example of this was we would receive an alert every time a Jira shard filled up. And that was a problem because my team was a platform team and we couldn't do anything about that. Only Jira could do something about that. And that meant that we would receive alerts and we couldn't do anything about them. And finally, we realized we had two states that our application could be in: completely fine or on fire. Basically, we would never look at our operational resources until something fundamentally exploded. And that was a problem because we'd actually defined a service level objective, or SLO, against our application. So an SLO is just the level of service that you're willing to commit to offer. And this can come in a variety of different forms, but one example is availability. So you could say, I'm going to commit to having 99.99% of the requests to my application succeed. If you were to make that claim, try to think about how you would verify that you're living up to it. You're probably going to have to look at some kind of dashboard operational resource, right? And we weren't doing that. We were treating lack of alerts as meeting SLO. And it turns out we weren't the only team who were doing this. There were many teams across Atlassian who were experiencing similar pitfalls to us. And one of those teams was a very large team over in Austin, and they had 70 microservices that they were trying to maintain. And so from an operational standpoint, that got pretty crazy. So eventually one of the members of that team said, okay, this is enough. And they introduced a process to Atlassian called TechOps. So TechOps is this crazy idea that you should have a process dedicated to regularly reviewing, discussing, and iterating on operational health. And it is worth pointing out, we did not invent TechOps at Atlassian. This is something that's been around for quite some time from other companies such as AWS. But this particular team executed TechOps in 5 steps. They first sat down and developed some measurable goals that they wanted to work towards with respect to operational health. They would then look at those goals and think about the data that they could collect to verify how they were tracking and reaching those goals. That data was then used to prepare a report. So a typical TechOps report would include things such as all of the alerts you'd received that week, a ticker across for whether each service had met its goals, and a summary of all of the notable anomalies and events. They then sit down and have a discussion about the report. And during that time, it was expected the team would start to raise questions and identify actions. And they did that every single week. And this team experienced a huge amount of success in rolling out TechOps. So we rolled it out company-wide. And we were one of the many teams who decided to jump on board. So we sat down and we defined our goals. And we figured we're receiving way too many noisy alerts. And so we wanted to do something about that. And collecting the data for that was pretty easy. We just looked at the alerts we'd received that week. And just kind of FYI, it was actually 87 low priority alerts that we'd received. And the vast majority of them we ignored. So that's not so great because that's in addition to our actual real high priority stuff, but it gave us something to work with. So we took all of those alerts and we put them onto a report. And in addition to the alerts, we put a screenshot of all of our dashboards at a given point in time, as well as a summary of all of the incidents that we had received. And then at the end of the week, we sat down and had a discussion about the report. We noticed some really, really good conversations come out of that. We would start to question how actionable each of our alerts were. So were they indicative of a real customer-facing problem that we could actually do something about? We would question how discoverable all of our resources were. So during an incident, did the engineer feel as though they could quickly and easily find everything they needed? And we would ask ourselves how useful our stuff was. So did we have things that nobody ever looked at? And conversely, did we have blind spots? And in having all these conversations, we started to identify a lot of actions and the data kind of spoke for itself. So here we see a real graph of the first 21 weeks of TechOps showing the number of alerts that we've received over time. And we were far from the only team who had these benefits. Here's another team showing a massive increase in reliability due to TechOps. And then similar to us, very large team, very large reduction of alerts. So how can you verify that you're measuring the right things? You have to review those things, and not just once, but frequently. It turns out operational health is not a one-time thing, and it's something that you constantly need to come back and iterate on. Okay, so we figured out what to measure, and now we've got this great process to make sure that we're still measuring the right things. But in rolling this out, all of a sudden there was a lot of change, and it was really hard to keep up with, because now we were agile and we're iterating on these dashboards and things all the time. And that meant somebody would sit down and define the new amazing dashboard, but you didn't realize it existed. Or somebody would update a monitor threshold and you had no idea that change had occurred. And so in this section, we'll just speak about how we try to be more proactive in keeping up with that change. In the beginning of this presentation, I showed you this diagram where the shard service looks at a variety of different metrics, takes the limiting factor and uses that to denote the overall capacity of the shard. Now, it turns out figuring out what metrics a shard service should look at was kind of a problem in itself because there were so many different resources and we weren't really sure what metric was going to give us a good understanding of their capacity. So in the beginning, we tried to do something super broad and capture busyness of a shard. So the idea here is that every time a product action would occur, we would fire an event and the shard service would consume those events. So the theory is that more events would correlate to greater busyness and greater busyness would correlate to greater resource utilization. So that was actually really good. It worked really well right up until we overloaded a database. And that was because sometimes a single operation would become this huge database query and you had a few too many of those and then it shit itself. But that's okay because now we know that we have to capture database metrics as well. Started firing database metrics. And again, this was looking really good. We're like, sweet, we've nailed it. But then the shard went down. So the shard service is looking at this nice little empty shard and sending all the customers there. And it was never going to work, but it looked pretty nice and empty. So we figured, okay, no worries. We'll start pushing out events every time we see a provisioning failure. And if we see too many failures, something's probably gone wrong and we're going to back off for a while. And so on and so forth. So that's kind of how it worked for a while. We would add a metric, have an incident, add a metric, have an incident, and keep working until things stabilized. So how is this related to operational health? Well, previously I showed you this little diagram where down the bottom we see a subset of all the different panels that we had defined for every metric that we had. And that meant that every time we added one of these new metrics, we had to go through this dashboard, through the UI and all our monitors and make a manual change. And that kind of sucked because it was pretty slow. It was very prone to error because you'd select the wrong service or the wrong environment or the wrong metric and just be completely wrong. But the biggest problem was it was super easy to forget. So you'd make your change in your code base and then you put that out for peer review and someone would be like, hey, don't forget to update the dashboards. And you'd be like, yeah, obviously. And then 20 other things will happen and you completely forget. And what we found was that this was very largely due to a massive separation between our application and our operational resources, where our application was this beautiful thing that we looked after really nicely, we cared for it really well. And then operational resources kind of lived over here. And we sort of looked at them sometimes during tech ops and when things went wrong. And so we started to look at some ways that we could reduce that gap. And we decided to do that by exporting all of the operational resources into code. And that meant that we could take that code and put it alongside the rest of our application. We also updated our build pipeline so that every time we were to make a change, we would, on commit, we would automatically take that code and push it out to the relevant tooling downstream. And this meant that the code was the single source of truth. So this came with quite a number of benefits. It meant that suddenly operational resources were front of mind. So they were no longer this separate thing that kind of lived over here, but actually now part of our application and part of our definition of done. Having everything in code meant that it was suddenly part of our Git lifecycle. So all of a sudden, operational resources were being reviewed. And when something went wrong, we could roll it back. And it came with the added benefit of making everything much more discoverable because now everything was actually defined in one place and you knew that code was the source of truth. And once again, we were not the only teams who were making this transition. There were quite a number of teams at Atlassian who had started to export their operational resources into code. And one of the first teams to do that was actually our site reliability engineers, or SREs. And the SREs, amongst many other things, had to maintain every single shard that we had in Atlassian. So that's the holistic application health of every single product that we had running. And that was very, very intense from an operational standpoint. I looked recently and saw that there are 286 dashboards defined for Jira alone. And these aren't simple dashboards either. This is low-level stuff. Here's a very small subset of one where we see things such as the number of threads that we've consumed and the JVM heap consumption. So now try to imagine if you had to add a new shard. Given that for every shard, we have about 5 or 6 different dashboards. You could go and manually create your dashboard through the UI at this level of granularity, or you can export everything into code and you can use templates. So the deal with the template is that you move away from having a dashboard for shard A and shard B and shard C, but rather a template of what you want that dashboard to look like, and then you define the shards to apply to that. And this isn't really possible without exporting everything into code. But once again, I mentioned, there's a lot of people doing this change, and Atlassian is quite large now, and so that was a lot of rework. And so one of my colleagues, Sergio Sinica, figured this can be solved at the platform level. And so during one of our 24-hour hackathons, we actually set out to just gather data about how Atlassians were going about solving this problem as it was. And of the 91 service owners who responded, we found that 83.5% of them were still maintaining their operational resources through the UI. We found that 67% were keeping their team up to date of all these little clicky manual changes they're making by tribal knowledge. And 23.1% were actually satisfied with their existing process. So the data was pretty compelling. We figured if we were to actually make this easier for everybody, there would be a real impact. We also had a quote from somebody saying, "We've been saying for eons that we should put our monitors and dashboards into code, but the task is too big to start, so we don't do it. Over time, the job just gets bigger and bigger and less likely to get done." So we figured we wanted to do something about this. And Sergio introduced this idea of Sauron. So Sauron was the all-seeing eye of dashboards and monitors. Basically, it was just a microservice, which knew about all the different tooling that we had internally. So basically, that meant that as a developer, I could come in and say, "Hey, Sauron, go and get my dashboard." And it would go and find that dashboard for me and export it into code. It would then send that code back to me, and I can put it alongside the rest of my application or wherever I want. If I were to make a change to that code, upon commit, Sauron would actually receive an event saying something has happened. And if it realized it cared about the thing that had happened, it would automatically take that code and push it out downstream. And that meant code was a single source of truth without any extra work on our behalves. And so just actually took this one step further because he realized everything was now defined in one place. So for every service that was registered with Sauron, he defined a UI to expose links to all of the different dashboards and monitors that had been configured. And so during an incident, we could log in, go and find this, and then find all the dashboards that had been configured and also our monitors if we didn't really know what they meant. Turns out this was a really, really good idea, and we've since seen over 50 services adopting Sauron. So some of these are very small, who are teams just getting started, through to some of our much larger teams such as Jira and our more highly critical platform services. So how can you help your team keep up to date with change? Well, obviously not everybody's going to go and build a Sauron to help their problem. It kind of depends on the scale of your organization. But regardless of how many people work for your company, we found it super helpful to start exporting everything into code because it helped drive that mindset where operational health wasn't separate to your application, but actually all the same. Okay, so I've spent quite a few minutes talking now, and so I'll just spend a couple moments covering everything that we've spoken about. To select what to measure, you really need to learn what questions you want to be able to answer with those operational resources. And that does require you to understand why your application exists in the first place and what failure means to that application. To verify that you're measuring the right things, we found it very helpful to review those things and to do it together with your team regularly. And to help your team keep up to date with change, we found it super helpful to start exporting everything into code and to drive that mindset where operational health is part of your definition of done. And it is worth pointing out, all three of these things are great independently, but we found them to have the biggest effect when applied together because you're still probably not going to know what to measure in leaving this talk. It's still really hard to figure that out. And you're probably going to get it wrong the first time, sorry. But it does mean that if you have this mindset where you're constantly reviewing that you're measuring the right things and you have a team who's focused on trying to improve this collectively together, you are much more likely to reach a point where you can eventually call yourself operationally mature. Thank you.